Bismillahirrahmanirrahim. Today we'll be discussing about voltage sensor, working principle, types and circuit diagram. What is a voltage sensor? A voltage sensor is a sensor used to calculate and monitor the amount of voltage in an object. Voltage sensor can determine the AC voltage or DC voltage level. The input of this sensor is voltage, whereas the output is the switch's analog voltage signal or current signal or an audible signal. Sensors are devices that can sense or identify and react to the certain type of electrical or optical signal. The implementation of voltage sensor and current sensor technique have become an excellent choice for the conventional current and voltage measurement methods. Type of voltage sensor. We can discuss a voltage sensor in detail. A voltage sensor can determine, monitor, and measure the supply of voltage. It can measure AC level and or DC voltage level. The input of voltage sensor is voltage itself and the output can be analog voltage signals which audible signals etc. In voltage sensor the measurement is based on voltage divider. We are familiar with voltage divider. Two main types of voltage sensor are capacitive type voltage sensor and resistive type voltage sensor. We'll mainly focus on resistive type voltage sensor. Here you can see we have only two resistors and the voltage output voltage is R2 divided by R1 plus R2 into V in. We know and here is our resistive type voltage sensor. Two ways exist to convert resistance of sensing element to voltage. The first one is simplest method which is is to provide a voltage sensor divider circuit comprised of a sensor and reference resistor which is represented below. The voltage developed across the reference resistor or sensor is buffered and then used to amplifier. The sensor output voltage can be expressed as Vout is equal to Rm divided by Rm plus Rf multiplied by Vref. This circuit drawback is that amplifier present will amplify the whole voltage and develop across the sensor. However, it is better to amplify only the voltage change due to the change in sensor resistance, which is achieved by second method implementation, the resistance bridge as shown. Basically, this is Wheatstone bridge, and this method is the best method. When R1 is equals to R, then output voltage becomes this, where A is gain of instrumentation amplifier and delta is the change in resistance of the sensor when analogous to some physical action. Here is our module. Some advantages of this module are that it is small in weight and size, personal safety is high, the degree of accuracy is very high, non-saturable, wide dynamic range, and eco-friendly. Application are power failure detection, load sensing, safety switching, temperature control, power demand control, and fault detection.